So now in this chapter we'll be looking at the datuming command. So so if you have a real system, so in a servo system, so probably you don't know where it's starting if it's 0 position. So the datum command actually to make it home, okay, starting from 0, and then you can calculate the position. So when you initialize the machine, so you need to know where the physically the axis is. So this is a system. I think we have it on the next room. So you have the track here, you have the home switch and the belt. Okay, so it will actually have an end position. So these are the steps for datuming. So where does it stop or where does it start? Okay. So the axis moves at speed, wait until the home switch and decelerate to a stop. You can have several types of deceleration. You can have a ramp stop, you can have coast to stop, or you can have the creep. Right, so once it's reached the home switch, it can slow down until. So axis moves in opposite direction until the switch is reset. And then it registers the current position, where you can see from the axis parameter what is the T-pos. So this is a typical action you'll always need to in the system. You need to keep in mind all the steps. You need to write a lot of lines for a simple task, but in this one you will see. So there are 6 variations available to use the inputs and the Z mark for the datuming. As I mentioned to you, there are several types of datuming you can do. Alright. So the keyword here is the datum, and you put in the sequence number. So if you go to the trio basic help, it will actually list down all the datuming sequence there. So 0 is for what, datum 0 is for what, datum 1, 2, 3, and all that. And datum in here is a value you assign the input. So you datum it by an input. So if you turn on input 0, for example, so that datums the axis. Alright, and the creep is sets the creep speed for the datuming. So once you reach the home switch or the datum position, so it will have a certain speed to stop there. So this is the example here. So assigning home switches. So you have base 0 datum input. So you assign switch 0 as an input for axis 0, and you say that datum input is for which axis. So axis 1. Right? And yeah, input works on the falling edge. So you have to make your input high before you this one. But if you don't want to do that, there is another command called invert in. So this one will automatically invert the state of the input. So you can put that as well. So if it's in off state, then you just have to switch it on to do the datum. Yeah, so you have this datum with commands. So you have to select the correct sequence for the datum input and the direction. So the datum 1 is always goes for forward, and datum 2 is for reverse, and then in datum 2 you have these other options like axis moving at creep speed. You can set the creep speed registers on the Z marker, decelerate to stop, or Z marking the position set as 0. Where else? In datum 3 and 4, if you can see, it goes here and it goes a bit further from the Z mark. Okay, so it creeps to the opposite direction until the switch is reset. So you can choose which type of datum you want to use in what situation.
Yeah, this one doesn't pay attention to the Z mark.
Yes.
Release the switch and then
yes.
Decelerate.
So in this one, the axis moves at speed. registers on the datum switch, decelerated to stop, but then it moves, continue to move until the Z mark, then decelerated to stop after the Z mark.
What's the difference between datum 1, 3 and 5?
In this case, so that's what, in this one, it doesn't actually see the Z mark, right?
Yeah.
So in datum 1, it has the Z mark. And in this one, oh sorry.
It's on the switch, yeah.
Yeah, it's on the switch.
And the last one is combination of the switch.
Switch and the Z mark.
Okay.
So this is more accurate.
Mm,
Yeah.
yeah.
Depends on the applications.
Depends on
Yeah, exactly. So it depends how you want to home your machine.
Yeah, for example, I have experience with the engraving machine for the good working CNC, and for the Z-axis. For example, sometime in the middle of work, the power gone,
Cuts off, yeah.
and they need to start from the exact same position. If you use only switch in that position, because you know the switch has kind of the variation position
Yeah.
based on the weather, you know, based on the situation, based on the lifetime of the switch. So the homing position get a difference by time, or suddenly maybe after power off and power on.
Then you have to calibrate again. Probably.
Exactly. So there is an offset, which is not good, you know, for precise applications. So the combination of the switch and Z mark gives you exact position always.
Yeah.
Because the Z mark is always the same position.
Alright, so we go to the program right now, so you can try, if you look at your, after, yeah, number 5 in your sheets, so you have the datuming routine. So what you can do is, you can do, okay, 5.3, but before that, let me go through some other things. So this is just an overview of how the program looks like. So the datum routine, you are running 2 axes and stop on home switch. So you can see they are using datum 3. So it's moving forward and it's on the switch. Right? And then they put await idle, so they suspend the program execution until the move has finished. Alright, working envelope. So what is working envelope is, in some machine you must have your limits, whether in forward or reverse. So working envelopes, basically you are setting the limits of your machines. So this you can do it through hardware switches or software limits, or you can set a special out of envelope declaration. So to do this, you have this command called forward in and also reverse in. So select which input to be used as a hardware limit in terms of forward and also reverse. Okay, and you also have this forward limit and also reverse limit, but this is in a position. So when you track your entire, for example, a conveyor, so you have like a 2 meters conveyor, so you can put in the position what is your limit step, or you can do it through an input switch. Selecting the correct sequence for datum input and direction. Default values exceed wrap this, so will never trigger. So this command we will come back later. So you can, if you put a wrap this on a program, that means it will repeat back the motion again in the same distance, so it will never trigger the hardware limits. Okay. So fast that is to do fast deceleration, so that you don't exceed the working area, right? If you are, especially if you are working close to the limit switches. And depth pause. Depth pause means this will set the current position to an assigned value. So if you put depth pause 0, x is 0, so whichever position it is, it will reset that back to 0. So same like a datum command. Same like a home position, 0 position. So this is about setting up your working area. So it uses a for loop. So for x is 0 to 1, move -5. So moving away from switch. So wait idle. So it says def pos 200. So it says the position where it is right now is 200, right? Then you put a fast deceleration, setting the deceleration for out of area, and you also set the forward limit and the reverse limit. So now, please add this new program Datuming to your project and follow the, sorry, that is not chapter 4, it's 5 actually.